I would like to give the floor to our colleagues from DNV, Harish, right? And then
Yeah,
Lino. So yeah, the floor is yours.
yeah. Thank you, Eduardo. So, good afternoon, everyone. I'm Arish Krishnappa, working within the team of Digital Grid Operations at DNV, together with my colleague Lino Parka, who is the technical product owner for Symbion, the conformance testing tool. We'll try to give you some highlights on SIM CGMES conformity, which will be followed up by a short demonstration of the Symbion tool. Next slide, please. Yeah. So to start off, so what is conformance testing? How is it different from interoperability testing? So basically, conformance testing provides you an assurance that your implementation or tool or application complies to a standard or parts of the standard. It is usually carried out in an audited environment through a accredited test lab, and there is certification of results for both positive and negative exchange cases. Uh, Usually conformance testing is a prerequisite for interoperability testing. And whereas interoperability testing is the ability to have your implementations or tools or applications exchange information, and these tests are usually positive tests. End of the day, if you want your implementation or tool or application to be successful, you must have both conformance and interoperability testing done. Next slide, please. So what's the added value of conformance testing? For instance, if you are a vendor, there is reduction in time for integration or implementation at your customer, and there is reduction of testing efforts, and of course, there's increase in your market share. And if you're a utility DER or aggregator, you get the assurance that you have purchased a well tested tool or a cost effective tool and an interoperable tool, which also confines to the EU network codes, for instance. If you're an association like ENTSO-E or EU DSO, then they are assisting utilities and vendors in the deployment of these international standards, which in turn will enable energy transition. For IEC and Senelec, they are promoting continuous use of these standards, also the evolution of these standards, of course, with support from the certification process. Next slide, please. Okay, and then we talk about conformance assessment scheme. If you want to know more about this topic, please have a look into the previous webinar, wherein our colleagues Swine and Chavdar try to explain the whole conformance assessment or CAS process in a simplified manner. However, within this CAS, that there are different roles and responsibilities defined. For instance, there is a scheme owner who is owning the conformity assessment process and the whole change process. There is an opinion body which is issuing opinion on the recommendations that were provided by the conformity assessment body. And then there is the assessment body, which is driving the process, including confirmation, communication, and review, which in this case for now is DNV. So DNV more or less is performing the conformance test on behalf of ENTSO-E. The opinion body is the SIM expert group within ENTSO-E, and the scheme owner is ENTSO-E. In the long term, the scheme owner will become IEC or Senelec once the CAS is part of the IEC standard. However, the SIM expert group would still remain the opinion body. Next slide, please. Oh, yeah. And for the roadmap, we foresee that IEC Senelec would become the accreditation body, followed by the certification body involving ENTSO-E, UCA, International User Group, or EUDSO. Whereas these certification bodies are working on various use cases, not only concerning transmission, but also distribution and coordination between TSO and DSO and other use cases. These are basically the scheme owners, which are in constant coordination with the accreditation body, which is IEC. Then there are laboratories, which are compliant to ISO IEC 17025 requirement, which could include DNV and others, performing tests on products from vendors or in-house developed utility applications. Next slide, please. Yeah, talking about the conformance testing services offered by DNV, we provide subscription services wherein a vendor, utility, or any user can access this tool using the web browser, upload the files, apply different test use cases, get validation reports, and do basically a self-assessment. And there is also something called as pre-conformance test that we offer based on our previous experience with protocol testing, wherein the vendor coming in for conformance test has the opportunity to figure out errors, if any, before actually appearing to the conformance test. And there's the conformance test itself, wherein we are using the test data, the test configuration defined within the CAS 3.0. We also provide SAT, wherein we are using utility data, and we also support utilities with business process testing. Talking about the whole conformance testing process, it starts off with the vendor providing the declaration of conformity, wherein he is declaring the conformity levels and the functions the tool supports. Based on this, DNV will tailor the test use cases and the test configurations for Symbion, which is the conformance tool, and then move on to testing, which can sometimes also be witnessed by some of the members from ENTSO-E, which then will lead to test reports. And then if there are no defects, then the vendor gets the attestation of conformity, and he also gets a place in the conformity registry, which is published on the ENTSO-E website. If there are any defects found, then there is a report created together with the help of ENTSO-E expert group, wherein the vendor is informed, the vendor goes back, updates the tool, comes back, and tests again. So overall, this process has several advantages. One, we are actually testing the standard itself. Two, we are testing the test use cases. So if we figure out any bugs or issues with the test use cases, they are reported to the SIM expert group within ENTSO-E, who will then try to figure out to fix the bugs or improve the standards in coordination with IEC. Next slide, please. Yeah, so finally, we talk about the conformance tool that we want to demo today, which is Symbion, which is an automated SIM testing tool. It's a cloud-hosted tool, so anyone with a web browser can access this tool and play with this tool. Basically, it reduces the integration and testing efforts. It has all the predefined test use cases. And yeah, basically it enables continuous use of use and improvement of SIM standard. In the bottom, you find the types of subscriptions available for the users. And up next slide. Yeah, we have a short demo prepared on Symbion, and Lino will be yeah. Over to you, Lino. Yeah.
Thank you, Harish, for the introduction and explaining how the process works. I will share my screen. And you should be able to see Symbion now. As Harish explained, there is something called the Conformity Assessment Scheme by ENTSO-E, which basically dictates how conformance testing is performed. And Symbion is built basically to make that process as simple as possible for the end user. Why am I saying that? If we set up a new test, there are three types. So if you remember from the presentation, self-assessment, pre-test, or conformance test, I will choose self-assessment simply because it's the least of configuration. But this is the part that I am talking about. And if you open, for example, the declaration of conformity from the ENTSO-E Conformity Assessment Scheme, you will find a document that looks very similar to this user interface, where basically you have to choose which profiles you support, which levels of import and export, and then below also which functions you support. So this is something that you declare that you are conformant to according to this scheme. So needless to say, there are very many interdependencies between what you choose here and what you also need to support. For example, if I say that I support steady state hypothesis and also, for example, that I support, I don't know, boundary, let's say import. And I want to say that I support topology processing. Then I get immediately a list of all the things that are necessary for me to support in order to perform this function. So this is the main, I would say, benefit of the tool, because if you take a look at the Excel file of the conformity assessment scheme, which shows basically the matrix of the dependencies of profiles, function, and test use cases, it is fairly complex, and this is simplified in this tool. So actually, you will see that there are no test use cases that you select. Rather, you will select the import, export functionalities per profile and the additional functions in general. And then as a result, if I go back here and just say one for the sake of simplicity, and that is the export of equipment, immediately we'll see here that the export conformity level is bronze. If I choose also another level of import, it will automatically go to silver. Similar for import, one level of one part of import inclusive is bronze, so either individual or inclusive, but either if you combine two types, then automatically it is silver. And as I click this here in the required test use cases, the tool automatically selects which test use cases I have to perform in order to satisfy these levels of conformity. So I cannot click or unclick this. This is pre-selected automatically for me. So rather than saying, yes, I support UC 5, 6, 7, you will say I can do equipment, import, export difference, SSH, TP, SV, and so on. And to show you simply how this works, then I will choose the most simplest configuration where I only do export of equipment. This will select automatically test use case 14, which is equipment export of equipment profile instance data. If I go next, at this step, I need to actually import the files. So all of those, only the test use cases that are relevant for this session are displayed. If I click on Manage Files, I get the question, would I like to run this on internal configuration or not? This is related to the fact that you can, because the CAS covers a wide range of use cases. One of them is a tool which cannot import, but only export. In this case, it cannot run on a standard configuration, rather it can run on an internal one. And this is what this question is about. So I say, no, I don't want an internal one. And in this screen, I get basically the entire description from the CAS of this test use case. What is the goal of this? Also a detailed explanation if I hover over this icon. And also for each test use case, I get the list of mandatory test configurations, in this case, full grid merge, and the list of steps to be performed with their description. So here it says the application needs to export the EQ data in a zip container and provide it to the tool. And if I then go here and click on the standard full grid EQ test configuration, upload it, fine. Now, when I uploaded all files, I can proceed to the actual validation step. And here it succeeded, which is not a surprise since I uploaded the standard reference test configuration. What happens if I do something very similar, only I introduce an error on purpose, which is fairly simple. And I will show you what it is in a moment. So I prepared a file based on this configuration, which is actually has a mistake in it. And if I run this now, I should hopefully get that it fails, and it does. And now when it fails, actually two things happen. So first I get a summary of all the types of errors. There can also be warnings and information. But the summary in where it actually shows the number of instances that are affected by this constraint violation. So since I only modified one object, it will be one. But actually we get 3 constraint violations regarding transformer and X value, rated voltage, and N number. And this last is actually, last constraint violation is pointing you to what I did, more or less. It says that it has a N number which is not unique, or N number 1 is not the highest voltage winding. And what I can do then is download the full report. And if I unzip it and find this error here detail, because this detailed report will list all the instances. So this can be thousands of lines long. This is why it's not shown in the user interface. Rather, it's exported as a Excel file. So, for example, I can see that all of these errors now relate to the same object. And if I copy this this ID, open this file which I made negative, open the input file and try to find this object, I will see that actually, in fact, I have switched the N numbers of this power transformer. So what was N number 1, I made 2, and then the next one, obviously, I made number 1. So this is a simple, I would say, almost trivial error, but simply just to show you how this tool works. And so the conformity assessment scheme contains really, I would say, hundreds, if not more, types of checks, and all of these are then performed on the input data. And of course, this is a very simple example where you have only one error, but you can imagine when you have error on a type, and you have, for example, a breaker, which then you have an error on that type of class, but then you have an error of all breakers in the instance file, which can then be thousands. And all of them you can find like this. Simply get a summary view of what are the problems on a high level, and then dig deep in the file and find the actual instances that violate the constraints. And that's all from my side.